We're going to go over A-7, which is applications of parabolas, 3 problems. Be sure to download the latest version, which is 1.2. It has a small change in problem 3 and fixed a couple other minor typos. Okay, so the first problem, a ball is thrown into the air and its height in feet is a function of time given by h of t equals negative 4t squared plus 16t over a limited domain shown in the graph. T is in seconds, all right? So we want to graph this function, but it's already graphed for us, so we don't have to worry about it. The big thing to notice is that down here, the parabola ends. It normally would keep going, right? The parabola ends, so it's going to affect our domain. We've talked about parabolas that are up vertical like this, up and down. Parabolas have an unlimited domain, meaning they go from negative infinity to positive infinity, but not here, right? There's no arrows at the end. This actually ends, okay? Because it's modeling a real life problem, although as in problem 3, we don't always see that. That's the case. We'll talk about that in problem 3. Okay, at what time did the ball reach the maximum height? At what time? You always have to ask yourself, what are they asking for? Because there's always 2 variables, right? If we were to make a table of values, we don't have to in this case, right? But if we were to make a table of values for t and h, right? At what time, that means anything in this column. They're looking for this column, right? They're looking for this column. Okay, so for example, this point here at the vertex, just reading it, is 2, 16, right? 2, 16, and this is the vertex, right? So it says at what time? So I'm looking for stuff in the green here. I'm not looking for the maximum height, even though it says the word maximum height, right? It says at what time? At what time did the ball reach the maximum height? Well, there it is. This is the t graph, so there it is, right at 2, right? Because this point is 2:16. That means at time 2, after 2 seconds, the ball has reached a height of 16 feet. So the answer is 2 seconds. Don't forget the units. You can abbreviate, but don't forget units. What was the maximum height? Okay, so now they're asking for height. When they're asking for height, h, then they're asking for this column, right? When they're asking for h, they're asking for this column. So that, the answer is 16. So notice, very small difference in the question. Make sure you answer it correctly. Okay, how long is the ball in the air? Well, how long means time. Time means t, right? And if we were to look at all the points on this graph, all of the t values go from 0 to 4. That's when the ball hit the ground again. So we're going to say 4 seconds, which also is the domain, right? The domain is between 0 and 4, which is what's next. What's the domain? Well, it goes as low as 0 and it goes as high as 4, right? There are no other x values. For example, if you try to look for, if I tried to plug a -1 in here, although you might get an answer from the formula, you would not get an answer from the graph, right? If you go to -1, which is right here, you can't find the graph. It doesn't go there. The graph never has an x value of -1. Okay, what is the range? Well, the range is here, right? The range is this, how high it goes, right? Not how far across it goes or how much time, that's height, right? This was domain, which we just did. Domain is all possible x values. In this case, it's t, right? Our function is a function of t. And range is all possible y values. In this case, h, right? All possible h values. Well, it goes as low as 0 because it hits the ground, and it goes as high as 16. So it's bracket, that means including 0, 16, and that means including 16. If you used a parentheses, it means not including. At what time t did the ball hit the ground after being thrown? Well, right about here, right at the end of the parabola, 4 seconds. How high was the ball 1 second after being thrown? Okay, what does this mean? How high means what? What letter are you looking for? H, that's right, H. I'm looking for H, okay? And I want to know h when t is 1. So I'm going to plug in a 1 for h. Watch how I actually write how I actually do this. I write the function with parentheses. I'm replacing every t with a parentheses. I didn't fill it in yet. And then I go in and fill the t value. 1 second. So that's time, right? So 1 second. So I replace all the t's with 1. All right. And I get h of 1 equals 1 squared times -4, that's -4 plus 16, equals 12, right? So I get a new point. Remember, this was not a very valid point, so I'm going to cheat a little bit and make it plus 1 and 12. So 112 is right here, okay? Now, I didn't have to go through this. I'm just showing you this because on the quiz you won't have the graph. You could have just looked at the graph, looked at t equals 1, and of course gone up to 12. All right? But I did show you how to do it algebraically, so when you have that in the quiz, you'll know how to do it. How high was the ball 1 second after being thrown? 12 feet. Okay, what is the other time? So again, I'm looking for another t. I'm looking for t, I mean. What is the other time when this ball is at the same height as g? So g meaning part g, right? So this was 12 feet. When is the other time when the ball is the same height? So when the ball is 12? Well, it's right here. And that's because it's a mirror image across what? What do we call this? The AOS, axis of symmetry. Okay, and it's not labeled here because this graph skips every other one, but it's really at time equals 3, right? So at 3 seconds. Okay, let's go to problem 2. So on problem 2, we don't have a graph, so we're forced to graph this, right? And there's a lot of different ways we talked about it. One way is, of course, is to make a table, and we will make a table as we go. But this problem is factorable, so we're going to have a lot of values that come out of all of our work. But worst case scenario, you just make up t values in this chart and then find h values by plugging it in, just like we did in the other page. However, this h of t is factorable, so we're going to write h of t is factorable by a negative 3t GCF, right? Never leave a negative in front of the squared, even if there's no other numbers. And there's a t in both of these, so that's why the GCF is t. I'm actually going to put a parentheses around this because it's important to realize it's a factor. You don't have to. So minus 3t times what gives me negative 3t squared? And the answer is t, right? Negative 3t times t is negative 3t squared. And then negative 3t times what is plus 6, right? And that's going to be negative 2, okay? Be sure to double check your work by foiling it, right? If you, distributing it. So if you distribute this into t minus 2, you will get the original problem. Remember, when you GCF a binomial, that's a binomial, 2 terms, you get a binomial and the GCF. A lot of you like to just make one here and one there, right? And you say, oh, monomial times monomial, but it's not. You're gonna get another binomial just like you had here. The GCF does not reduce the number of terms. It just takes some of the factors out. Okay, now why do we factor this? Why do we factor this? Because we actually want to set it equal to 0, right? We want to say that h is 0. See, I'm gonna make this 0, right? H of t, 0. So 0 equals negative 3t times t minus 2, right? Right? I want to set both of these because if this is 0 and this is some number, let's say it's like 8 or something, right? Actually, it'd be negative 2, but if this is 0 and this is negative 2, whatever, 0 times 8 or 0 times negative 2, doesn't matter, will equal 0. I don't have to have them both be 0 at the same time. Either one can be 0. So I'm setting each factor equal to 0, one at a time, okay? And then we'll solve both of these. Just divide both sides by negative 3, and you get t equals 0. Add 2 to both sides, you get t equals 2. Okay, what does that mean? That means at 0 and at 2, those are my 2 zeros, I get a height of 0. How do I know the height is 0? How do I know this height is 0? Because I plugged it in right here. Look at, right? I know this because I put 0 right there. That's what I did. I said let h equal 0, and what would happen to t? And I got 2 t values that make h equal 0. Why are they so important? Because those are the points where we hit the x-axis, right? That's the x-intercept there and here, okay? Now, once we get 2 zeros, it's actually very easy to know that the vertex is at 1, right? Because the axis of symmetry, the center line, is right down the center of this parabola, so it has to go between these two. So right away, I know that the vertex has an x value of 1. If, and this will happen in the quiz, if I get a parabola that does not factor, then I have to use this method, right? Minus b over 2a. Okay, I have to use that method. And actually, we don't want to use x in this problem. That's the formula we use, but it's actually t, right? So we're going to say, in our case, it's t equals negative b over 2a. Remember that b is the coefficient here. It's the coefficient of the second term, that's 6. So it's 6. And a is the coefficient here, which is negative 3. All right, and what do I get? I get negative 6 over negative 6, which is equal to 1, which is no surprise at all because it's right there. I'd already found it because it's halfway between these two zeros, right? This is 0, this is 1, and this is 2, 3, 4. So I know it's right here. Now I got to plug 1 in. So I'm going to use my h function. So I'm going to say, well, if that's the t value, what's the h value, right? Or if that's the x, what's the y value? So it's negative 3 times 1 squared plus 6 times 1. Always use parentheses, even in a simple one like this when you're substituting in, okay? And you get 1 squared times negative 3, that's negative 3, plus 6 is 3. Okay? And that's my vertex, 1, 3. There it is. Now, this is a pretty simple parabola. It is upside down parabola. How do I know that? Don't forget that's always on the quiz too, upside down parabola, because this is negative right there. So that means it's upside down. So I know that this is a maximum, and it's going to go like this, and it's going to go like this. Now, you're all wondering, well, why don't I find more points? And why don't I like put points down here and here and here? Why don't I go look for those? Why don't I make a table, plug in 3 or something? Because right here in the very beginning of the problem, only positive h values, right? Only positive. All h values, you know, all up here, that's all positive, right? But this is negative. Anything down here is negative. So I stopped drawing the parabola as soon as I hit the x-axis. And that's it. So I really don't need any other points. At what time did the ball reach the maximum height? At what time? That's t. So what's my t value at the vertex? Well, the t value here is 1. Okay, 1 second. What was the maximum height? The maximum height was 3 feet, right? 3 feet, because that's the y value of the vertex. That's the y value, okay? How long was the ball in the air? Well, the entire parabola starts at 0 and ends at 2 in the, again, t-axis. This is the t-axis. This is the h-axis. So it's 2 seconds. What is the domain? Domain is all possible x values. In this problem, though, it's t values. So it's bracket 0, comma 2 bracket. What is the range? Remember, range is all the possible y values, or in this case, h values. So it's just from 0 to 3. At what time t? I'm looking for t, not h. I'm looking for t. Did the ball hit the ground? Right here, 2 seconds. You could write t equals 2 seconds if you want to. You don't need to. How high was the ball? 0.5 seconds after being thrown. This is slightly different from the one sheet you had because I updated it to version 1.2. So you can just change it manually right there. Just change it because the other question was not so interesting. Okay. What am I going to do? I'm going to, how high? So how high means I'm looking for h. That's why h is unknown here. And this is going to be negative 3 times 0.5, but I'm going to use fractions. Fractions are much, much better. Squared plus 6 times 1/2. Okay, what's that equal to? Well, 1/2 squared is 1/2 times 1/2, which is 1/4, times negative 3 is negative 3 over 4, right? You change negative 3 over 1 times 1 over 4, you get this, plus 3. Now, this is 3, right? This is the number 6 here, so that's a 3. But I'm going to change 3 to be 12/4, so I need a common denominator. Okay, there's some middle school skills there. So this is equal to 3. This is equal to 3, but why would I bother writing 3? Because 3 is not going to help me. I need something over 4. So 12 over 4 is also equal to 3. If you divide 12 by 4, you get 3. And that's finally equal to 9/4, which is about, or actually it's exactly, I should say, 1 and 1/4. 2 and 1/4. 2 and 1/4. Right? 4 goes into 9 2 times with a 4th remainder. So at 0.5, which is right about here, halfway, maybe I'll use a different color for that. purple. So we're going to hit right about 2 1/4, which you could kind of see is the case, right? Not a big surprise there. So right about there. So that's the point they're looking for. So what is the height? It's 2 1/4 feet. And finally, what is the other time when this ball is at the same height as G, right? So in other words, when the ball is 2 1/4 feet. Well, that's 0.5 away from the red line. That's 0.5 away from the red line, right? Which happens right about there. So it's from 1/2 to 1.5, right? So at 1.5 seconds. Okay, let's go to problem 3. Problem 3, again, I have a parabola not graphed, so I'm going to graph it. And this parabola does factor, okay? C is temperature Celsius, and T is time. Now, they didn't tell us what time is, so I'm actually going to say time equals minutes. They didn't tell us. On the quiz, you would have that, but they didn't say, so you could call it anything you want, but we're going to use minutes. And we're going to factor it, right? We're going to factor it. There's no GCF. There's no GCF, but there is 2 factors of 5 that add to -6. So that's -1 and -5. Okay? So what does that tell me? Well, that just tells me that if I want to know where the x-intercepts are, or in other words, where the temperature is 0, right? Then I know that one of these factors has to be equal to 0. So let's set them both equal to 0, right? So we're going to say t minus 5 could equal 0. That would make it work. Or t minus 1 could equal 0. They would both work. And of course, add 5 to both sides. I'm not going to spend the time showing you that work. You get these two. So what does that mean on my table of values? And again, on some problems, you're going to make a table. On some problems, we don't have a nice factoring like this. So we have to make up most of the values, except for, of course, you could put C of t or just C. Actually, I'm going to put just C. I mean, it's absolutely right to put C of t, but I'm just going to make our lives a little bit easier. And we just found 2 points, right? We found 5, 0, and 1, 0. Don't be tempted to say 5, 1 or 1, 5. These are 2 t values, right? They're t values, see? They're not c values. The c value is 0 because that's what I put in here. See, I replaced this with this. See, I made it 0. Okay, so let's plot them, right? Let's plot those 2 points. And of course, they're on this line. We're looking for x-intercepts. In this case, actually, technically it's a t-intercept, but I use x because, for discussion purposes, because that's what you're used to hearing, right? But it's t. So 5, 0, and 1, 0. Now, again, I could do my formula for the vertex's x value, right? So this is for the vertex. I could do this x, or in this case, t equals minus b over 2a, and I sometimes have to do that. That will give me this number here that I'm about to find, but I don't need to, because in this graph, if I was to draw my axis of symmetry right through the center, we know that it has to have a value of 3. So I know that the vertex is 3, and all I do is plug in 3. Okay, so 3 minus, sorry, I messed up. I don't want to use the factored version. I want to use the original version. C of 3 is 3 squared minus 6 times 3 plus 5. Okay? And that's going to be equal to 9 minus 18 plus 5, which is equal to -9 plus 5, which finally equals -4. Okay? So I know the vertex is 3, -4. I know it's a facing up parabola because right here, this is positive, right? There's no negative number there. There's no negative sign there. So I know it's positive. So I know it's going to go up like this. But I'm going to get some more points, though, to help me draw this parabola a little bit better. One of the freebie points we always talk about is the y-intercept. You just put in 0 for x, not 0 for y like we did before, or in this case c, but 0 for x, or in this case t, right? So we're going to put 0 in for t. So I plug in 0 right here. This is 0, right, minus 0 plus 5, right? So we get a freebie 0, 5. 0, 5. That's the y-intercept, right? And we should do that for every parabola because it's really free. It's really the easiest thing to do. And that always gives you one free point. Now the other point I'm going to find out is 2, right? So let's see what happens at 2 with t equals 2. And I'm going to do it really quickly because we're running out of time, but I'll just, you know how to plug it in. So you're just going to plug it in back up here in the original equation. We're going to plug in 2. So it's 4 minus 12. I'm just doing it in my head here. You can, of course, write it out. 4 minus 12 is negative 8. Negative 8 plus 5 is negative 3, okay? And I'm going to get a mirror point, right? So if I go to 2, negative 3, which is right here, you know you're going to get a freebie right here, right? Which is 4, negative 3. That's our freebie point because of the symmetry. And finally, I'm going to draw my picture. And remember here, of course, don't forget. Oh, and I got to go through that point too, so I kind of messed up a little bit. Don't forget to put arrows at the end, okay, that let us know that it goes on forever. And see, this has no domain restriction. So even though in real life we can't get as hot as the sun, or we could get as hot as the sun, but we can't get much hotter than that. So the temperature is going to go on up and up and up and up forever. Okay, so at what time is it coldest, right? Coldest means what? The lowest temperature. So remember, whenever we have a positive or an up-facing parabola, we know that this is a minimum. I'm going to abbreviate, but it's minimum. And if it's an upside-down parabola, like in some of the other problems we had, it's a maximum, right? But this is, at what time is it coldest? That's a minimum, right? The minimum temperature. Well, the minimum temperature, don't say 3. It's not 3. It's the y value of the vertex, right? It's the temperature. This is temperature. C is temperature, so it's minus 4 degrees. Degrees Celsius, right? We'll put degrees, even though we know it's Celsius. Okay. What is... I'm sorry, I messed up. That's this problem here. I don't know why I skipped that one. What was the coldest temperature? I'm sorry, this said at what time? See, I made the same mistake, which is good. I did it on purpose. No, I didn't really. But I made the same mistake. I read it too quickly because I'm rushing. At what time is it colder? So they want time. Time is t. They're looking for the t value. See, they're looking for this value. So that's 3 seconds. So even your teacher who's been teaching for 18 years can make the same mistake you can if you rush and you don't read it carefully, which is what I did. Versus B, which is the one we answered a second ago, which is what was the coldest temperature, right? What was the coldest temperature? That's C. That's the C value. That's the temperature, okay? So don't make the same mistake I did. And I'm happy to make it for you so you don't have to. Minus 4 degrees. Okay, how long was the temperature below 0? Freezing, right? So freezing. Freezing is below 0. How long was it? Well, all of this from here to here, this is all below 0. And it happened from 1 to 5 seconds. So that's a total of 4 seconds. What is the domain interval notation? Okay, so the domain goes basically forever to forever. Okay, because they said there was no domain restriction. What is the range? The range is how hot and cold it will be. Well, it will get as cold as -4, but never colder than that, according to this graph anyway. And it will go hotter than the sun to infinity. Okay, it's not realistic, but they were specific about no restriction here, so that's what we have to follow. At what times did it switch from below freezing to above freezing, right? That's very important. So from below to above. You might be tempted to say this, but that actually went from above to below. Remember, time is a forward arrow, right? Time goes forward. So as you go left to right, you had to be freezing and then get hotter. Right here, it was cold, cold, cold. Suddenly it was 0, and then it was hot, or warmer, let's say, right? So there's not 2 answers here. There's only 1, and it's at 5 seconds, or 5 minutes, I think we said 5 minutes. Yeah, I made a mistake earlier, so sorry if you were a little confused. This is 5 minutes, right? Minutes. Because that's what we defined up here. Even though they didn't specify, we wouldn't be wrong for writing seconds. But we decided to use minutes, let's stick to it. Okay, the hardest problem in the whole thing, and this will be on the quiz, so please pay extra attention to this one, right? At what time did the temperature reach 45 degrees? Let's not make that same mistake we made before. They want to know what? T or C? At what time? T. They're looking for T. Okay, so this 45 degrees is C. So we're going to plug that in for c. So if I take my original equation, which was c of t, I'm going to replace the c with 45. Okay, and if I scroll up just to look at it again, I'm going to put all of this here and solve for t. So I replace the c, here's the c, with 45, and I'm going to write t squared minus 6t plus 5. See, I'm solving for t, so don't plug anything in for t like we're used to doing. Okay, how do we solve a quadratic? How do we solve a quadratic? We set it equal to 0, so we're going to subtract 45 from both sides. And we're going to get 0 equals t squared minus 6t minus 40. And I'm going to need we have to factor it, so I need 2 factors of 40. That's subtract to 6, right? 2 factors of 40. There are different signs here. This tells me I'm going to have plus and minus. This tells me I'm going to have plus and minus, right? So I know I'm going to have plus and minus. So the numbers are going to subtract to negative 6. So 2 factors of 40 would be 10 and 6. But the 10 has to be negative and the 6 positive. I'm sorry, not 10 and 6, 10 and 4, my bad. I'm rushing again, 10 and 4. So 10 and 4 is 40. 4 times 10 is 40, that's 40. And it's negative 40 actually. And when you do the inners and outers, so the inners is 4t and the outers is negative 10t. When you add up negative 10 and 4, you get negative 6. So there we go. It's not the answer though. Don't forget, that's factored, set equal to 0. So we basically break it into 2 problems. We say t plus 4 equals 0 and t minus 10 equals 0. I'm not going to do all the work there. You know, you've done this a million times. T equals 10, t equals negative 4. Now, sometimes we would ignore the minus 4 because sometimes our problems will start at time equals 0, and we will never have backwards in time. But this didn't give us a domain restriction, so really both of these are valid. So we're going to say negative 4 seconds, right? No, not seconds, minutes. Negative 4 minutes. And 10 minutes. There's 2 answers. Okay, if you want to say t equals, that's not a bad idea. I want to say t equals negative 4 and t equals 10 minutes. At what time? That means they're asking us for t, and they gave us c. So we had to plug in 45 for c and solve for t. Okay, that's it.